Hi everyone, welcome to my YouTube channel again. And in this class, I'm going to start talking about the ARC, which is anti-reflection coating. We use this mechanism because of the light characteristic. Um, because the light when the light comes into the wafer, some constructive interference and destructive interference can occur. So to prevent this problem, we use anti-reflection coating. As you can see here, when wave 1 and wave 2 comes into the wafer, they have the same phase, so the constructive interference occurs. And in this case, they have a difference with 180 degrees of phase difference, so the destructive interference occurs. So we are going to use this method to reduce the constructive interference. In For this ARC, we use Bragg's law, which is 2D sine theta equals to n lambda. When the light comes in to the wafer, when the constructive interference occurs, uh, the difference between the distance is d sine theta. So we can write, there are two d sine theta, so we write 2d sine theta and equals to n lambda. As you can see in this diagram, when the light comes in, there may be some constructive interference coming in to the silicon. So this is the PR, and in this part it is the intercept of PR and silicon, and this is a silicon material. So as you can see here, the light comes in and the constructive interference occurs, so we have to prevent the constructive interference, so we put anti-reflection coating over the PR. To continue, there are two ways of making anti-reflection coating. From now on, I'm going to say ARC. If the constructive interference occurs, then more part of wafers can be reduced than we expected, and for the positive PR, and for the negative PR, there may be more materials remaining than what we wanted. So this is the reason we use the ARC. So for the top ARC, we put the ARC over the photoresist, and for the bottom ARC, we put the ARC under the photoresist. We usually call the bottom ARC bark. And now we're going to compare the top ARC and bottom ARC. For the top ARC, we use polymer. It is just like a soft liquid. And for the bottom ARC, there are two methods, which is organic bottom ARC and inorganic bottom ARC. For the organic, we use polymer for high absorption. And for inorganic way, we use SiON, which is very hard material. Okay, so for top ARC, the method is we use THC control and destructive interference to avoid the constructive interference. And for the organic bark, we use absorption in bark. And for the inorganic bark, we use the same way as top ARC. And however, the top ARC cannot be used for hard mask, and they if we put a coating over the PR, the coating may not be properly working, because we put a top ARC over the PR, then the PR can be melting. For the organic bark, it is a very simple process because we just have to coat under the PR. But there may be some thickness variation, and it has a very poor edge selectivity. Also, it may cause some defect and making some problem with PR when we match them. For inorganic bark, it is very conformal, and it has a very good edge selectivity. However, it takes a lot of time, so there are some pros and cons between these three methods. Now, I'm going to introduce you about the PSM, which is phase shift mask. We also use this phase shift mask because of the characteristic of the light. When we expose the light over the reticle, and if the light is exposed and some part where we want it to hide can be interfered and make some patterns. So we don't want these things to happen, so we use the phase shift mask. One way of using phase shift mask is to put a phase shift material which has 180 degrees phase between the reticle. So if the light get exposed, then we use the destructive interference. So the part where we didn't want the light to be exposed can be disappear, and this is one of the knob of the constructive interference. So actually we use using a 180 degrees phase shift material, we call it attenuated phase shift mask. And another way of using PSM is alternating phase shift mask. We use a different material like glass and air to change the phase. We make some space in the glass and we expose it with the air, so this destructive interference occurs and makes and solve the problem making constructive interference. As you can see here, here's the quartz, and we put some space here and making a phase shifted space, so the destructive interference can occur. Now I'm going to introduce you with the OPC, optical proximity correction. When we want to make a pattern, let's say we want to make this blue pattern. However, when we expose the light, this pattern doesn't occur because in the edge part, the light gets rounded and makes this orange line, and where the line gets when the line gets intercepted, the pattern gets broadening. So the real pattern will occur like the red line here. So the target pattern were the target pattern was the blue line. However, when we expose the light without any correction, the red line occurred. So we have to make a correction like green line. So to make a target pattern. In the next class, I'm going to talk about the OAI, off-axis illumination, and I'm going to continue talking about the photolithography. Although my curriculum is very slow, however, I want to make sure that you get the right knowledge about the photolithography because it is a very basic statistic to learn about the fabrication of semiconductor. So I hope you enjoy my channel today, and thank you for watching.